Good morning, students. Today we are going to study an important topic from data structures, that is hashing. Let us first understand what hashing means. Hashing is a technique used to store and retrieve data efficiently. Instead of searching data one by one, hashing allows us to directly access the required data. A key is converted into an index of a hash table using a hash function. Because of this direct mapping, the average time complexity is O of 1, which means constant time. This is why hashing is widely used in databases, symbol tables, and compilers. Hashing mainly consists of three components. First, the key. This is the input value such as a roll number, employee ID, or phone number. Second, the hash function. This function converts the key into a numeric index. Third, the hash table. This is an array where the data is stored at the index generated by the hash function. All hashing operations depend on how well the hash function distributes the keys. Now let us see what a hash function is. A hash function maps a key to a fixed table index. One of the most commonly used and exam-friendly hash functions is h of key is equal to key mod table size. This function is simple, easy to compute, and frequently asked one. So here the mod is nothing but a modulo function. The modulo function is denoted by a percentage symbol. It returns the remainder obtained when one integer is divided by another. Now, let us apply the theory using a worked example which is very important. Here, the hash table size is 10. The hash function used is h of key, that is equal to key mod 10. The keys given are 23, 43, 13 and 27. We will now calculate the hash value for each key step by step. Let us calculate the hash value for each key. So 23 modulo 10 gives 3, 43 modulo 10 gives 3, 13 modulo 10 gives again 3, 27 modulo 10 gives again 7. So these 3, 7 values are nothing but the reminders of those divisions. We observe that 3 keys map to the same index, that is index 3. The situation is called a collision. A collision occurs when multiple keys are mapped to the same index. One common method to resolve collision is chaining. In chaining, each index of the hash table contains a linked list. All keys that hash to the same index are stored in that list. In this example, index 3 stores 23, 43, 13. Index 7 stores 27. Chaining is simple and effective but requires extra memory. Let us analyze the time complexity of hashing. In the average case, search, insert, and delete operations take O of 1 time. In the worst case, when many collisions occur, the time complexity becomes O of n. Therefore, a good hash function is very important to maintain performance. A very common real-time example of hashing is a phone directory. The key is the phone number. The hash function may use the last few digits. The value is the person's name. This allows instant searching instead of scanning the entire directory. To summarize, hashing provides fast data access using hash functions. Collisions are unavoidable, but they can be efficiently managed using techniques like chaining. Choosing a proper hash function improves performance. Hashing is widely used in databases, compilers, operating system, and real systems. So this is one of the most important exam definition. Hashing is a technique that maps keys to addresses in a hash table using a hash function to achieve efficient data access. So this is the simple definition of hashing. So thank you.